let's talk about something we've all dealt with, but maybe never really thought about. Software bugs. We're going to dig into why they happen, what they really are, and uncover the surprisingly massive cost hiding behind a single glitch. All right, let's get into it.
I mean, of course you have, right? It's that universal moment of frustration. Your screen freezes up, a button does absolutely nothing, or you get some cryptic error message. It feels so random, but here's the thing. It's not. There's a story, a chain of events behind every single one of those failures. And that story almost always starts way before you ever click that button.
And, while a crashing app is super annoying, the real consequences of a software bug can be so much more serious than just ruining your afternoon. We're talking about major, real-world impacts.
And this is where it gets really serious. The scale of this problem can be staggering. It's not just about a few dollars lost here or a few minutes of your time wasted. A single, tiny bug can cause massive financial meltdowns, it can completely destroy a company's reputation, it can trigger enormous lawsuits. And in the most critical systems, think about aviation or medical equipment, it can, tragically, lead to serious injury or even death. This is why getting software right isn't just a nice-to-have, it's an absolute necessity.
So if we want to prevent these disasters, first we have to understand what a bug even is. It's not some kind of mysterious ghost in the machine. Nope, it's a clear, traceable chain of events. So let's perform an autopsy on a bug.
Everything starts right here, with an error. And this is the most human part of the whole process. It's just a mistake, a slip-up, a programmer is tired and misunderstands a requirement. Or maybe they just type a less than symbol when they meant to type a greater than. It's a simple, honest-to-goodness human mistake.
Okay, so that human error then creates what we call a fault, or a defect. Now the mistake is no longer just an idea, it's physically in the software's code. This fault is like a little landmine, a dormant bug just sitting there in the code, totally silent, just waiting for the right conditions to be triggered.
And this is the part we all experience, the failure. A failure only happens when the software is actually running, it executes that line of code with the fault, and boom! The landmine goes off. The software does something it wasn't supposed to, it deviates, the app crashes, the wrong number shows up, the website just spins and spins. The failure is the loud, visible symptom of that quiet, hidden fault.
So you see the chain, right? It's a domino effect. A person makes an error. That error creates a fault in the code, and that fault can cause a failure when you run the program. And understanding this flow is everything. Because if you can catch the error when it's made, you prevent the fault from ever getting into the code, and the failure can never, ever happen.
Okay, so we've got the chain of events down. But to be really smart about this, we have to go all the way back to the beginning. Where do these really critical, super costly mistakes usually come from? Now, your first guess might be pretty obvious. During the coding phase, right? I mean, that's where all the complex logic is written. And sure, tons of errors happen there. But the most dangerous, most expensive ones, they often start way earlier than that.
And here it is. This might be the most important part of this whole explainer. Many of the most catastrophic faults get baked into the system before a single line of code even exists. It happens way back in the user requirements phase, when the team is just talking about what the software should do. A vague instruction, a misunderstood feature, a detail that gets missed. That's the seed. That's the foundational error that the entire expensive project is then built on top of.
So, this leads to the million-dollar question. And sometimes it's literally a million-dollar question. If you make a mistake in the architectural blueprint of a house, what's the cost of fixing it when you're already putting on the roof? As you're about to see, the answer is astronomical. This really gets to the heart of it. It's not just if you find a bug. It's when you find it, and that one factor determines everything. Okay, just look at this chart. It's incredible. If you find and fix a bug during that early requirement stage, let's call the cost 1. A 1x cost. Manageable. But if you miss it, and it's not found until the coding phase, the cost to fix it jumps by 10 times. And now, what if you miss it again? What if that bug makes it all the way out to the customer, into the live product? The cost to fix it explodes to 100 times the original cost. Why? Because now you have to go back and unravel everything.
The code, the design, the testing, the deployed systems. All to fix a simple misunderstanding from day one.
And hey, don't just take my word for it. This is a foundational principle proven time and time again in software engineering research. The longer a defect is allowed to live in a system, the more entangled it becomes, and the more expensive and chaotic it is to rip it out. The cost just keeps climbing.
So after looking at a chart like that, the solution becomes crystal clear, doesn't it? It all comes down to one thing: finding those errors as early as you possibly can.
It really all comes down to the power of when. Yeah, finding bugs is important, obviously, but when you find them is what makes the difference between a successful project and a total disaster. Catching a mistake in a document is a cheap, easy fix. Catching that same mistake after the product has launched can sink a company. And that means truly great, reliable software isn't about hiring superhuman programmers who never make mistakes because they don't exist. It's about building a perfect testing process that catches those inevitable human errors early, long before they can ever grow into failures.
So I want to leave you with this. The next time you use an app or a website and it just works, it's smooth, it's flawless, it does exactly what you expect, just take a second to think about the invisible success story you're not seeing. The real masterpiece isn't just the code that works, it's the army of testers who found all the ways it didn't work and fixed them before they ever had a chance to get to you.